So the first thing we have to do is required to prove as a P. We are required to prove that A multiplied by A inverse is equal to I. So the first thing I'm going to need to do is find A inverse. Recall, and you notice the all of the statements that I'm making, please, right? Recall that A inverse is equal to 1 all over the determinant of A multiplied by the A adjoint. So that is 1 all over the determinant of A is 2A multiplied by D, which is 2 times 3, minus 1 times negative 5. Yeah? And if it is that I'm doing anything wrong or making any mistakes, just please let me know, because sometimes I can make mistakes too. Okay? And then we multiply that by the adjoint. So for the adjoint, we flip these two and we put negative signs in front of these two. So that means that this negative 5 is going to become a positive 5. And so we have the adjoint. So therefore A inverse is equal to 1 all over 2 3s are 6. And this is going to become plus 5. So 6 and 5 is 11, being multiplied by 3, 5, negative 1, and 2. So yeah, everything seems to be fine there. And I'll just leave it like this for now. I'll just leave it like this. You notice I'm not actually making the multiplication of the determinant just yet. Because it looks simpler like this. You see that 11 can't really cancel out with anything there. So now, to prove A times A inverse equals I implies. Notice the clear statements. You could follow the story going down the road, right? So I have the A times the A inverse. So I'll put the determinant in front, and then I will put AD in just on 5, negative 1, 2, and then I'll put A, which is 2, negative 5, 1, 3. And let's see what we end up with, right? And I hope I put that in the right order. So we'll see. Notice I'm leaving the determinant outside. So 1 over 11. And let's go with it. 3 times 2 is 6, plus 5 times 1 is 5. Ooh, that looks good. 5 3s are negative 15. And 5 3s are positive 15. Okay. 2 1s are negative 2. 2 1s are positive 2. And we have here 5, negative 5. No, negative 1 times negative 5 is positive 5. And 2 3s are 6. So we could see here that we have 1 over 11 into 11, 0, 0, 11. And then, well, obviously the scalar is going to cancel. So we will get 1, 0, 0, 1, which is the identity, which is the proof. So you see here, we started with the required to prove. Anything that we had to remember, we will write recall. And we follow through the statements nice and easy and proved it, right? Anybody have any questions? All right, so the next one is proving that A multiplied by the identity equals to A. Proving that a number multiplied by 1 is itself, right? So let's do part B over here. Required to prove that A multiplied by the identity is itself. So let's go with A being 2, negative 5, 1, 3. Multiply by 1, 0, 0, 1. This is pretty easy. We have 2 times 1 is 2. Negative 5 times 0 is 0. 2 times 0 is 0. Negative 5 times 1 is negative 5. 1 times 1 is 1. 3 times 0 is 0. 3 times 0 is 0. No, sorry, 1 times 0 is 0, and 3 times 1 is 3. And what do we end up get? 2, negative 5, 1, 3. And that is A, and that is the proof. Alright, so nice easy questions here. Csec and Scotia, you guys okay with this?
First question.
Okay, no problem. And you definitely want to keep up with me when it comes to writing this stuff down. And if it is that I'm going too fast, let me know, and I will slow down. Right?
Yes, sir.
So,
Yeah.
alright. So please, it's just little simple things that you have to know, right? So if it has a determinant of 0, well, that'll help you because you know that the determinant is therefore for k 4, 5, negative 2. That means that the determinant is what? K times negative 2 minus 5 times 4, right? And that's how you find the determinant, and we know it's a singular matrix, so the determinant is equal to 0. You see how easy this ended up being, Scotia? Right? So negative 2k minus 20 is equal to 0. Negative 2k is equal to positive 20. K is equal to negative 10. And we're done. So here's what, and I'm pretty sure that Sarah and Caitlin didn't do it. So what I'm going to do is I'm going to do the first one, and then I'll give you guys a little 5 minutes to do the others. Right? Now, the first thing I'm going to make sure is that my x's are in a line and that my y's are in a line. And if they're not, you know, then you rewrite your equation so that they will be. Yeah? And seeing that in all of these equations, the x's and the y's are in a line. So what I will do is I will form the matrix. So I have the x's on this side, 3, 1, that is the coefficient of x, 3 and 1. On this side I have 2 and 4. Yeah. And then you put this xy here. And then that is equal to, on this side you have your 1 and your negative 3. And what you say is of the form A times x is equal to b. And therefore, if I multiply both sides by A inverse, then A times A inverse will be gone. Or if you want, you could think about it like flinging over the A. So therefore, A inverse times B is what x will end up being. Yeah? So all I have to do is take A inverse and multiply it by B. Right? So let's first find what A inverse is. A inverse is 1 all over the determinant of A, right, times the adjoint, and I'll just put the adjoint 1 time 4, 3, negative 1, negative 2. Yeah, so that is 1 all over the determinant is 4 3s are 12 minus 2 1s are 2, 4, negative 2, negative 1, 3. So therefore that is 1 all over 10 into 4, negative 2, negative 1, 3. You notice I am not going to multiply my determinant yet. Yeah, I'm not going to do that yet. So therefore x is equal to A inverse times B. So x now, which is xy, is equal to A inverse 1 over 10 into 4, negative 2, negative 1, 3 times b, which is 1, negative 3. And you notice I'm keeping my determinant outside, and I would not multiply that until the very last, right? So let's multiply the matrices first. Right? We should get, if this is a 2 by 2 and this is a 2 by 1, we should get a 2 by 1 as the answer, right? So we see here that 4 times 1 is 4, plus negative 2 times negative 3 is positive 6, right? We see here that negative 1 times 1 is negative 1, and 3 times negative 3 is negative 9. So that gives us 1 all over 10 into 6 and 4 is 10, and this here will be negative 10. And of course, when you multiply the scalar, you'll end up get 1, negative 1 as the final matrix. So therefore, x, y is 1, negative 1, which implies that x is equal to 1, y is equal to negative 1. So you see here, I put it in the form a times x is equal to b. Therefore, x is equal to a inverse times b. So to find a inverse now, a inverse is equal to 1 over the determinant of a times the adjoint negative 1, 5, and then negative 6, positive 2, right? So 1 over the determinant gives us 5 ones are negative 5 on this side, minus 6 twos are negative 12 on this side. And I want you to notice that. Let me write that a little bigger, right? Because this is one of those things that could mess you up. I could imagine both of you all making mistakes right here, right? The determinant is 1 all over. The determinant is if I take 5 and multiply it by negative 1, right? Minus 6 being multiplied by negative 2. Notice how I have the brackets there, right? Into negative 1 to negative 6, 5. Right? So this is my determinant here. So you can see how I get 5 times negative 1 is negative 5 in here, minus, and then 6 times negative 2 is negative 12 in here, right? Just now it's supposed to be 1 over the determinant. Oh, that. 1 over the determinant multiplied by negative 1, 2, negative 6, 5. Notice how I keep writing over the same thing. So negative 5 plus 12 is negative 7, is it? Negative 5 plus 12 is positive 7, sorry. So that's 1 over 7 into negative 1, 2, negative 6, 5. Alright, so this is my determinant here. Because that double negative means that that will become plus 12, right? So therefore, X is equal to A inverse times B. X is equal to 1 over 7 into negative 1, 2, negative 6, 5 times B, which is 12, 13. Right? So that is 1 over 7 into negative 1 times 12 is negative 12 plus 2 times 13 is 26. And 6 with 6 times 12? 6 times 12 is 72. So that will be negative 72. Plus 5 times 13. 5 times 13 is 65. So that is 1 over 7 into 26 minus 12 is 14. That worked out pretty well. And negative 72 plus 65 is negative 7. So you can see here that when we multiply the scalar, we're going to end up getting 2 and negative 1. Therefore, xy equals 2, negative 1, which implies x is 2, y is negative 1. Scotia?
Yeah, I got that.
Lovely. Beautiful. Ooh, oh, that's not good. Shazay?
Yes, sir.
Alright. So let's check out this last one here now, and then we'll move on with the other questions. So we have here our matrix negative 5, negative 7, 2, 3, right, is equal to 24, oh no, not equal to, I have to multiply it by xy, and that is equal to 24, 35. So therefore, that is in the form A times x is equal to B, and x, and therefore x is equal to A inverse times B. So now let's find A inverse. A inverse is 1 all over the determinant of A times A adjoint. I'll find the adjoint one time is 3, negative 5, and then our positive 7, negative 2. Right? So 1 over the determinant is 5 3s are 15, negative 15 minus 7 2s are negative 14. Right? So I have negative 15 in this bracket minus negative 14 in this bracket. 3, negative 2, 7, 5. So that gives me negative 15 plus 14 is negative 1. So the determinant here is just simply negative 1 into 3, negative 2, 7, and negative 5. So now x is equal to A inverse, which is negative 1, which is the determinant, 3, negative 2, 7, negative 5. And I mean, in this case, you could multiply the determinant one time, if you wanted to. But I'll just leave it outside for the sake of procedure. This is 35 over here. Ooh, I'm gonna see that I'm gonna get some really big numbers there. So 3 times 24. Ooh, negative 1 outside. 3 times 24. 72 plus negative 2 times 35. 35 times 2 is 70. So that is minus 70. Oh, okay. Or maybe it might not get so big number. And then 7 times 24. 168. Plus negative 5 times 35 is 175. So that's negative 175. So what do I get? Negative 1 outside of 72 minus 70 is 2. And 168 minus 175 is negative 7. And I hope I didn't make no mistakes anywhere. Yeah. So therefore, that is when you multiply the negative 1 now, you'll get negative 2 here and 7 here. Therefore, xy negative 2, 7. Which implies that x is negative 2, y equals 7. Yeah?
Yes, sir.
Alright, lovely. Alright, beautiful. Let's move on now. So, in the last class, we were taking a look at some transformations. and we had some transformations. We took a look at the reflection, and we saw that there are some couple, it might look complicated, Scotia, but it's actually really simple, so you'll just check out the video. The videos have actually now officially been uploaded to YouTube, so it's just a matter of me putting them in the Google Classroom, so I'll do that as soon as class is done, right? So literally just now you'll be able to look at our videos. So these are reflections, the formulas for reflections, the formulas for rotations. And really and truly, I mean, honestly, I would love you to know these formulas by heart, but translations is, and you can see translations is one of those topics where, you know, transformations is one of those topics where common sense will help you out, you know. Also remember we have the enlargement and such. So let's take a look at some of these transformation questions here, right? On the answer sheet provided, ABC is mapped onto A prime, B prime, C prime under a reflection. So, and it's hard to read, but this is ABC, and this is A prime, B prime, C prime, and it's under a reflection, and we could see here, without looking too hard, that this will be the mirror line. Yeah? Write down the equation of the mirror line. Well, I can see that this here is the mirror line, and you know, it's a vertical line. A vertical line has an equation x is equal to 5. This is the line x is equal to 5. Every point on this line, x is equal to 5, even if the y points are changing, right? So this here, the equation of the mirror line is simply x is equal to 5. 1 mark, you're good to go. Now they say A prime, B prime, C prime is mapped onto A, B, C double prime by a rotation of 180 degrees about the point 5,4. So, I'll just erase all of this. About the point 5,4 is about here, so, right? And they say that this is mapped onto this by 180 degrees, right? A rotation of 180 degrees. So we could definitely see here that this point B corresponds with this point B here, B prime, and that rotation there is 1 of 180 degrees about this center point there. Alright, cool. We could see all of that. Determine the coordinates of A prime, B prime, C prime. Well, I don't have to determine nothing because you give me a graph, and the graph looking real nice and exact. So I could just read off the points of the graph. So this point here is the point, so A prime. Yeah, this A prime, A double prime. Yeah, this here is just, if this is B double prime, this will be C double prime. So this is A double prime, yes. So A double prime here is 1, 2, 1, 2. B double prime is 3, 2, 3, 2. And C double prime is 3, -1. And boom. So that is our 3 answers there. So we can actually write down for part 2, A double prime is 1, 2. B double prime is 3, 2. C double prime is 3, -1. Right? So right, that's part 2. And part 3, state the transformation that maps the original ABC to the double prime. Right? So what transformation, and I'll just erase these here. What transformation will map this onto this? Well, we could see that it's not a translation, because a translation means that it would have looked the same, right? We can actually see here that it is a reflection, and this here is the mirror line, the line y is equal to 4. And so for 2 marks, we can see that the transformation is a reflection, and reflection is given by M, isn't it? So if you wanted to show off, you didn't have to write this, but you could have show off and say M, a reflection in the line y is equal to 4, right? Or a reflection in the line y is equal to 4. Right? So you could see here that even though we did the full topic on transformations, it was mostly a common sense thing. Yeah. So anybody have any questions on this one? Okay. Next transformation question here. ABC has those coordinates, right? And we can see the coordinates here. On the answer sheet provided, draw A prime, B prime, C prime, the image of ABC under an enlargement with the center O, right? And a scale factor of 2. So what do we know when we have an enlargement of a scale factor of 2? Is if A is 1, 2, this implies that A prime will be, the scale factor is 2 multiplied by 1, 2 multiplied by A, which is simply 2, 4. Right? B prime is 2 multiplied by the point B, which is 4, 2. So that is 4 2s are 8, 4. C prime is just 2 multiplied by 1, 0, which is 2, 0. Yeah, so you just multiply the scale factor by your points. So now we have A prime is 2, 4. So that is A prime there. B prime is 8, 4. So that is B prime here. C prime is 2, 0. So that is C prime there. And we can see that this is the enlargement that took place. And it's an enlargement with center 0. So we can see that if we connect that and that and that, they all will intersect at that center 0 there. All right. Any questions on this one? Okay. Now the triangle A double prime, B double prime, C double prime is the image of the original ABC under the transformation M. Describe completely the transformation M. Well, we could see here that this is the double primes, A, B, C double prime, and this is the original image. We could see that it didn't have no flipping or rotation. We could see that this thing generally just basically slide down. It slide down, so it's a translation, right? So, and they say completely, so we want to be as thorough about it as possible. Right? It's 3 marks here, so let me see if we have 3 things to write at least, right? So M is a translation where the object, which is ABC, is mapped on with a translation T to the image double prime, A double prime, B double prime, C double prime, right? Where, right? And the translation T is what? What is the actual translation T? Because we see here that this is moving down. Yeah? It's moving down by some vector being translated. So let's just take this point C. The point C connecting with this point C. And we'll see here, where does C have to move to? Well, it has to move 1, 2, 3, 4 spaces horizontally. So 4 on the X. And then 1, 2, 3, 4, 5 spaces vertically, but it's down. So it's -5, just like what we saw in vectors. So this here completely describes the transformation M. It is a translation of 4, -5. Any questions on this one? Shazzy, Skushal, you're good?
Yes, sir.
Soraya, you good?
Yeah.
Alright, Soraya definitely want to sleep. Soraya,
No.
you eat food today?
I had breakfast.
No lunch?
I didn't have lunch yet.
Way, alright. I get okra rice for lunch. I had lunch today, yay.
My mom made spaghetti, but I'll eat that later.
Wow, I did not have to teach today because it was a public holiday, so I canceled all of my classes except you guys because you're all lame, right? Scotia, are you awake?
Yeah.
All right, good. You're okay with you're okay with this, right? This seems pretty straightforward to you, right?
Yeah.
Even though you missed the class, it really is a kind of common sense kind of thing, right? This one here was quite a bit tough actually. It's an older question. State the scale factor and the coordinates of the center of enlargement. Right? So you see I have an enlargement here, and they say to state the scale factor of the enlargement and the coordinates of the center of enlargement. Well, the scale factor of the enlargement, we could actually see it. We could actually see that this side is 2 blocks and this side is 4 blocks. We could actually see that this side is 3 blocks and this side is 6 blocks. So we can see 3 times 2 will give me 6, 2 times 2 will give me 4. So for part B, oh, we're part A, boy. Look, part A down there. Okay, locate the center of enlargement showing clearly. Alright, well, part A and part B. What? Here now, let's do this. Watch part A. Locate the center of enlargement showing your method clearly. And then part B, write the coordinates for the... Why wasn't this just in part A? Why? You could have... Because I had a... Fine. Alright, fine. So the scale factor... not scale with a K. Scale factor equals 2. Alright? So we could see that there. That wasn't hard to figure out. So we just looked at the length of it. Now let's look at how we find the center of enlargement. And of course, for the center of enlargement, you guys actually will have to use a ruler. So make sure you have your ruler there. And take one point, join it to the corresponding point, and then just extend it going out. Right? So we have that there. So you see, we take this point and the corresponding point, we join them, right? So now let's join another one, right? We'll take this corner point here and join it to that corresponding corner point there and extend it. And you see where the two of them intersect right there? No, that's not it. Let me just move back this line. Oh no. Yeah. So what we did was we take this point and we just draw a straight line to this point, and then we extended it until it you know, and we could do that again. Copy and paste. Oops. No. Stop it. We could do that again with the third point. If we take the third point and we connected it to the corresponding point there and then extended it, well, now we see that all three of them converge at this point over here. So it's like if this point is the Big Bang and the universe came out of that, right? So this point here is the point 1, 5. So therefore the center of enlargement equals 1, 5. Notice for part A, locate the center of enlargement, showing your method clearly. Well, this is the method. You join the corresponding points and extend it until they meet, right? And that would be a center of enlargement. Determine the value of the area of the bigger triangle divided by the area of the smaller triangle. Well, this is hardly a transformations question, but let's just do it real quick. The area of PQR divided by the area of LMN equals, so a half the base, which is 4, the bigger one up on top, times the perpendicular height, which is 6, right? Divided by a half the base, which is 2, times the perpendicular height, which is 3. So 6 4s are 24, divided by 2, which is 12 on top here, and 3 2s are 6. 6 divided by 2 is 3. So therefore 12 divided by 3 is 4 is the answer for part C. Draw and label A, B, C with those weird coordinates respectfully. Alright. Just erase these here. So draw and label A, B, C. The first coordinate is negative 4, 4. So negative 4 is on this side, positive 4 here. So that is A. B is negative 1, 4. That is here, B. And C is negative 1, positive 2 here, C. So this is the shape there that they wanted, and they gave me 2 marks for it. Thank you very much. Describe fully the single transformation. You notice they said single. Please, especially Scotia, all of the words that you get are supposed to be important. Single transformation, right? Because I could say I could achieve getting from here LMN to triangle ABC, LMN to ABC. What is the transformation? I could do that in many different ways. If I want, I could rotate this here first. That's all. If I rotate it there, and this will come down so. No, and this will be here. Wait. No, yeah, I had it correct the first time. Yeah. So I could rotate it about this point first, and then I could translate it up like that and translate it so like that, right? So it have many ways that you could move something, but they don't want that. They want a single transformation. That means one transformation that does the entire job. So we could see that the transformation that does the entire job, if we take this C point here, this C point corresponds with this end point in terms of being the same point, right? I could see here that if I connect that to the origin, that is a diagonal across 2 square units. If I connect this to the origin, that is a diagonal of across 2 square units. And this is about 90 degrees. Yeah? And you could tell that it's 90 degrees. So you could see here that this single transformation is a rotation anti-clockwise. So C, for 3 marks, the first mark is a rotation anti-clockwise. The second mark is of 90 degrees. And the third mark is about the origin 0, 0. Nice. So, Shazay, how you feel about this one?
Good.
All right. Okay, nice. So, okay. Any questions on this? No. All right. So let's see if we can finish up today's class. We have some things to talk about. We have we did this one last class, right? So we wouldn't do that again. Right? Now we have some past paper matrices questions. Yeah, past paper matrices questions. The first question is this: calculate the values of A and B such that A multiplied by B gives you that. Scotia, did you do this? Alright, what about you, Shazay? You got to this question? Well, I mean, imagine you just have to multiply, right? You have to pretend that you're multiplying. Yeah? And when you pretend that you're multiplying, look, they gave you the answer. They give you this matrix times this matrix gives you this matrix. So this matrix is the answer. Yeah? So if you take this and multiply it by this, you're supposed to get this, and therefore you could find A from that. Then if you take this, or you could find A by taking this and multiplying it by this to get this. Alright? You Scotia, Shazay, y'all want to try it? Yeah. Alright, Shazay, you understand what to do?
Yeah.
Alright, I'll give you all 2 minutes, right? Soraya and Caitlin, I hope you guys following along.
Yes, sir.
You notice I'm not harassing all you much. Soraya and Caitlin, you guys are gonna be widely off the hook for the next 2 weeks. For the next 2 weeks, we're just gonna be drilling past papers. Remember, Soraya and Caitlin, that you guys should at least be able to do most of the past papers, eh? So I wouldn't let you guys totally off the hook just yet. But really is my Form 5s that I'll be drilling over these next 2 weeks here leading up to the exam. Right. So with matrix multiplication, you're supposed to know, and I'll just write over everything here. A negative 4, 1, B. 2, negative 4, 1, negative 3. That is equal to 2, 0, 0. So all you need to recognize, and please guys, when you're doing a question and you see something like this, just remember they cannot ask you something that you do not know. You know. So don't be like, I don't know what to do for this. No, you're overthinking. Because all you need to do is multiply. Look, make sense of what you're seeing as a multiplication, but you have the answer. Yeah? So, I know that if I multiply this, A times 2 and negative 4 times 1, I am supposed to get this here. Alright, I'm taking this and I'm multiplying it by this, and I'm supposed to get that. So therefore, A times 2 plus 1 times negative 4, and I'm supposed to get 2. Okay? So 2A minus 4 is equal to 2. 2A is equal to 2 plus 4. If I throw the 4 over, it'll become 4 plus 2, which is 6. A is equal to 3. 6 divided by 2. And you notice I skip a couple of steps there, so I hope that you guys are mature enough to know the steps that I skipped, right? So we saw A is 3, And we saw, well, B now, if I take this, just now, let me just erase. Right. For B, if I was to take this and multiply it by this, I would get this. Yeah? So 2 times 1 is 2 plus B times 1 is B, and that's supposed to give me 0. Therefore, B is negative 2. Right? Simple, nice and easy. See how easy that was? Nothing tough at all. It's just all the problem is, especially you, Csec and Scotia, you guys just wanna think too much, and you all don't remember the simple little things that I just keep talking about in class. It's the simple things that has helped you. You know? It doesn't. None of these questions, none require any kind of complex genius thinking. None of these questions, right? So do not let this math exam scare you. You don't have to be a genius. It's just a matter of thinking simply, right? Hence or otherwise, write down the inverse of that. I mean, yeah, I know how to do it hence, but I don't need to do it hence. I could just do the inverse of that, right? So the inverse of that, and let me just move this. Right next to it here. So the inverse of that, and I want you to notice that this and this is the same. So they're asking me for the inverse of that matrix. So 2, -4, 1, -3. Let's call it matrix A, right? Because they didn't give us any name for the matrix, which is very bad manners. Yeah. So therefore, A inverse is equal to 1 all over the determinant of A times the adjoint, which is equal to 1 all over the determinant 3 times 2, that is -6, minus 1 times -4 is -4, right? Multiply by the adjoint, which is -3 here, 2 here, -1 here, +4 here, right? So now I will get -6 plus 4 is -2. Yeah, I hope so. Let me know if I'm doing anything wrong. -3, 4, -1, 2. And you can leave your answer like that. This is A inverse, right? So you can leave that determinant out there. That is no problem at all. So A inverse is just simply that. And they say here, use the inverse of this, which is what we just found, to solve for x and y in the matrix equation below. So we can see here that they gave us the same matrix, multiply by that, and they give us that is of the form A times x equals B. They are asking us anything that we don't know. We know everything, right? So therefore x is equal to A inverse times B, and look, they already made us work out the inverse over here. So that is -1/2 into -3, 4, -1, 2. -3, 4, -1, 2. And we're multiplying that by 12, 7, which is that matrix B on that side there. So what are we going to get? -1/2 into 12 3s 36, is it? So that is -36 plus 7 4s are 28. And then on the bottom here we have -12 plus 7 2s are 14. Yeah, I hope I did that right. So 36 -36 plus 28 gives us -8 on the top here. So this is -1/2 negative 8 on the top here, and this will be negative 2 at the bottom here. So you know that this negative will make everybody positive. And a half of 8 is 4, and a half of 2 is 1. So therefore, x is equal to 4, and y is equal to 1. And they say solve for x and y. Yeah? This is what they're asking you for. So please make sure and you state, you make a statement and state your answer. Okay. Shazay, Scotia, you all okay?
Yes, sir.
All right, nice. So Scotia, tell me how to do part A for this one. Given that D is that funny looking thing, is a singular matrix, determine the values of P. Very good. No, the singular matrix is not equal to 0. Come again. What is the matrix itself equal to 0? Come again, Scotia. You almost had it right. You told me a singular matrix is equal to 0. What is equal to 0? The matrix itself? Shazay, character? The determinant of a singular matrix is equal to 0. You understand?
Yeah.
All right, very good. So let me just say, recall, this is the matrix D, so I will say that the determinant of D equals to 0 for a singular matrix. All right. Let me just write over D on this side so I can do my working on this side. 1, 9p, p, and 4. Nice. So therefore, the determinant of D is this 1 times 4, 1 times 4. And you notice something, eh? Real cheeky. They say value, but with a S. So that implies, well, maybe P might have more than one answer, right? So you had to look out for all of these little things, you know, that little S there, right? So back to the determinant now is 1 times 4 minus 9p times p, and that is equal to 0. So we could see here that this is 4 minus 9p squared is equal to 0. So now I could see what's going on here. Wait, now what's going on here? Listen, and the determinant is 1 times 4 and then p times 9p, and you minus them, right?
Yeah.
All right. I'm not wrong there, right?
No.
All right. Okay, all right. So then I fling across the 4, so now I have negative 9p squared is equal to negative 4. That is right. And now I'll have p squared is equal to negative 4 divided by negative 9, right? Which is positive 4 on 9, right? Or I could say that that is 2 2s are 4. No. Can 9 go into 4? No, it can't, right? 4 on 9 is just 4 on 9. 4 on 9 is just 4 on 9. So now P and you notice how cheeky it is with that little s. P is equal to the square root of 4 on 9. And if you know your rules of indices, you know that that is the same as the square root of 4 all over the square root of 9, which is 2 on 3. Right? But it's not just 2 on 3. because when we're dealing with square roots, we're talking about plus or minus 2 on P. So therefore, the values of P is plus 2 on 3, or P can also be negative 2 on 3. Everybody cool with this, Scotia?
Yeah.
All right, lovely.
So who will have that other answer?
You will lose some marks. Yes, you'll probably lose like 1 mark if you didn't have the other answer. Because I mean, they went out of their way to put a little hint here, and yeah, they went out of their way to put a little S there. You know, they could have saved the ink. You know. So you probably wouldn't lose a whole mark though. You might like lose a half mark or something. The procedure is what they're looking at. Right? The procedure is more of what they're looking at. Right? So let's look at the this other one. We're given simultaneous equations here. Write the equations of the form. Well, first of all, let me just write down the simultaneous equations real quick. 2x plus 5y is equal to 6. 2x plus 5y is equal to 6. And 3x plus 4y is equal to 8. 3x plus 4y is equal to 8. Am I making any mistakes there? Nope. Right. Now, they say, part 1, write the equations of the form ax plus b, where a, x, and b are matrices. I think we should all be able to know how to do that. So that is 2, 3, 5, 4, x, y equals 6, 8. Right? And please do not just write that there for part 1. Don't just write that. Be polite. Be professional. So write is of the form ax equals. Right? Calculate the determinant of the matrix A. Well, I think you know where they're going with this, right? I think that they basically take a simultaneous equation question and they say, well, first you had to calculate the determinant of A here, then you had to show that A inverse is this. So look at that. They did not trust you to figure out A inverse yourself. They actually gave you A inverse. Just in case you got it wrong, then you would not get the next part wrong. You could have used A inverse from that. Use the matrix A inverse to solve for x and y. So it's essentially a simultaneous equation question, but in pieces here. So part 2 is calculate the determinant of the matrix A. So part 2, A, the determinant is what? 4 2s are 8, minus 5 3s are 15. Right? So that is 8 minus 15 is negative 7. So the determinant is negative 7. Hence show that A inverse is equal to that. Well, we can see here that part 3, A inverse is equal to 1 over the determinant negative 7 times A adjoint, which is 4, 2, negative 3, 5. And of course, you can see where everything is over 7. Right? So you can see how that happens there. Right? Yes. So we could see here that they did multiply. So that gives us 4. Well, negative 4 over 7, negative 5 over 7, 3 over 7, negative 2 over 7. I think they got something wrong though. Oh no. So how come this 5 not negative? Oh, I supposed to have a negative here for the adjoint. You see? Nobody didn't correct me. I just teaching myself and everybody else sleeping. That's what's going on here. Alright? So 4, 5, 3, and the negative 2. I should have negative 4 here, yes. So, and please, you put your proof. This is the proof. Alright, so they ask you to prove that A inverse is this. Well, you did it. You multiplied it by the adjoint, and you showed that. So now that you have the A inverse, use the matrix A inverse to solve for x and y. So you know part 4. X is equal to A inverse B, which is A inverse negative 4 on 7, 5 on 7, 3 on 7, negative 2 on 7, multiplied by B, which is 6, 8. Right? I actually don't want to do it like this because I'm feeling lazy right now. So I am going to pull back out the determinant on the outside. Actually, no, I wouldn't do that. Should I? Let's just do it like this, right? So that gives us this multiplied by 6, right? Negative 4 over 7 times 6. Plus this multiplied by 8, 5 on 7 times 8. And then on the underneath, I gotta have 3 over 7 times 6 plus negative 2 over 7 times 8. 6 fours are 24 over 7. Oh no, I didn't add 5 8s are 40 over 7. And then 6 3s are 18 over 7 plus 8 2s are negative 16 over 7. So that gives us 40 minus 24. I have a feeling it's 21. It's not, it's 16. Alright, so this is 16 over 7. And this one here is 16 minus 18 is 2 over 7. Not very nice answers though. Yeah? Nothing could really be reduced or anything here. Yes, I could take 16 over 7 and put it as a mixed fraction, but I'm feeling lazy. So you know what? So therefore, x is equal to 16 over 7. Y is equal to 2 over 7. And that is it. Any questions with this one? So you could see here that in this one, they actually gave us simultaneous equations, but in pieces. Right? In pieces. And the reason why they give it to you in pieces is because just in case you found the inverse and you got your inverse wrong. If you got the wrong A inverse, if A inverse was wrong, then you would have used the wrong A inverse here and gotten this wrong too. So that is why they actually gave you A inverse. And they asked you to show that A inverse is this. So even though you could not show it, even though you didn't know how to do it, at least you could have had the correct A inverse to use for the next question. So I actually had to give them credit. This question was pretty decent. I just wish that they had used prettier numbers, because those answers are really ugly looking. Right? I think this, just 2 more questions here, and we'll call that a day for today. So let me just do these questions quickly. The matrix M is defined by that. Determine the value of P for which the matrix does not have an inverse. Scotia, what? You want to help me here? And I have a reason why I'm asking you, Scotia.
Yeah, I know.
What's the reason?
Not get it correct.
No, you got it correct the last time. So let me see if you can get it correct this time.
The determinant and zero.
Right. You notice they didn't say anything about singular though, eh? What did they say? They say it does not have an inverse, eh?
Yeah.
And remember what we were saying? We were saying that a singular matrix does not have an inverse, eh? Because if it is that A is a singular matrix, then 1 over the determinant of A times the adjoint, right? That'll mean 1 over 0 times the adjoint, which is impossible, right? So they could use the word singular, or they could, they try to be real sneaky here. They actually purposefully did not use the word singular, and they just said M does not have an inverse. If M does not have an inverse, that could only be because it's singular, right? So therefore, the determinant of M is equal to 0. That implies that 7 times -1 plus, oh no, it's supposed to be minus, minus 2 times P is equal to 0. So -7 minus 2P is equal to 0. -2P is equal to +7. Therefore, P is equal to 7 on -2, which is -3.5. Alright, so P is -3.5. Thank you very much. And express the equations of the form here, blah blah blah. And wow, they didn't ask you to actually solve it, eh? Oh look, this last question is the same as the question before. I guess I copy and pasted it twice. So this is the last question we're doing here. And thankfully in this last question, they actually did not ask us to solve it, right? But we'll solve it anyway, why not, right? 4x minus 2y is 0. 4x minus 2y is 0. And then 2x plus 3y is 4. 2x plus 3y is 4. 2x plus 3y is 4. And is that it? 2x plus 3y is 4. Alright, yes, nice. So, they just wanted us to put it in the matrix form. So the matrix form is 4, 2. And hopefully this is the kind of question you'll get for your exam. -2, 3. xy is equal to 0, 4. And that's it. That's good. That's everything, right? But let's try to actually solve it. And, they didn't ask us to solve it, so maybe it's not solvable. So this is not part of this question, but I'm just going to solve it just for the sake of it, right? So A inverse, the inverse is going to be 1 over the determinant, 4 3s are 12, alright, minus 2 times -2 is -4. Alright, well, at least the determinant looking real. And then by the adjoint, which is 3, 4, -2, and +2 up here. So that is 12 and 4 is 1 over 16 into 3 to -2 and 4. So now let's multiply x is equal to A inverse times B. So that gives us 1 over 16 into 3 to -2, 4 into 0, 4. Interesting. So that will give us 1 over 16 into 3 times 0 is 0 plus 4 2s are 8. And then -2 times 0 is 0 plus 4 4s are 16. Ooh, that worked out pretty nice. So why didn't they give you the rest of the question? I find they should have given all of the rest of this question to work out, right? Because now we have 1 over 16 into 8 and 16 here. And so we have here on top we'll have a half, and on the underneath we'll have 1. So therefore x is equal to a half, y is equal to 1. That was a nice question. They should have asked you the full thing.